WordPress Accessibility Day 2023. Plot a course. Accessible SVG charts in WordPress with speaker Joni Halabi, Senior Web Developer, Georgetown University. This presentation was recorded September 28th, 2023.
My name is Julie Johnson. I am an e-learning accessibility specialist, and again, welcome to WordPress Accessibility Day 2023. Thank you for joining us for Joni Halabi's presentation, Creating Accessible SVG Charts in WordPress. Joni is a middle-end web developer at Georgetown University who likes to write code, commit often, and make up her own titles. She has spent the last 20 years developing solutions for a wide variety of industries and organizations. She currently specializes in developing CMS themes and WordPress editor customizations. Joni has also taught continuing education coding classes and spoken at a number of technical conferences. When Joni is not writing code, she is writing technical articles and creative works focusing on life as a single mother by choice. She enjoys running, practicing yoga, reading, and seeing live music near her home in Washington, D.C. Please feel free to add your questions to the Zoom Q&A, and we'll answer them at the end of the session. You can use the chat to connect to other attendees. So go ahead and go, Joni.
Thank you so much. Hi, I'm just going to share my screen. All right, there we go. So hi, everybody. Welcome to Plot a Course, Creating Accessible SVG Charts in WordPress. My name is Joni Halabi, and just like in the introduction, I'm a senior web developer at Georgetown. You can find me on most social media at Joni Halabi, and regardless of what happens with social media, you can always find me on the web at jhalabi.com. So I am mom to a 5-year-old, and as she likes to say, enough. So we have a lot to talk about, and we have about 40 minutes to get through it. So let's get down to business. So today's journey, I'm just going to pose a story to everybody to start us out. So University Admissions comes to us and says, we want a visualization, a chart on our website that will show us how many students from each state in the United States who are returning to campus this fall. And University Admissions has an incredibly large spreadsheet of data. So what do we do with this? Our mission is to make this visualization on our WordPress website. So we're going to write a custom Gutenberg block to both interpret and create a chart out of this data. So let's set a course. So this presentation is going to be in 3 parts. Step 1, we're going to create that Gutenberg block so that we can read the spreadsheet data directly from our Google Sheets. Step 2, we're going to process that data in a way that we can use it to create a visualization. And step 3 is to actually make this chart. So we're going to make it accessible and we're going to make it responsive. So step 1, let's create this block. So we have 2 choices, really. We could manually enter all that data from our Google Sheet, or we could automatically import it from Google. I know which choice I would make. That automatic import sounds so much better. If we automatically hook up WordPress into Google Sheets, our data will update automatically whenever admissions goes in and updates that spreadsheet. However, there are a couple of trade-offs. So we will need to acquire an API key from Google. And it also means that our website now has an external dependency, which I know can be a deal breaker for some sites. So it's something to just keep in mind. If you like to keep your site very, very contained, this might not be a great option. But if you are okay with external dependencies, having that dependency on a Google product, this is a really nice automatic solution. So let's dive in. So our Gutenberg block setup, it is going to be a dynamic block, meaning that the content and the markup will be rendered on the fly on page load by the website's backend. And this is because we have dynamic data. This data could change. It's coming from a sheet that could possibly be edited at any time. So we're going to create a dynamic block. We are going to utilize block.json, and we're going to have a few attributes that we're going to define in this dynamic block. So we're going to define the URL of our sheet, which column to create a chart out of, and a title for our chart, and also a caption, just to give this chart a little bit more context. And we'll go into each of those as this presentation progresses. So I'm not going to dive too deep into the dynamic block creation, just because I really want to concentrate on the chart creation. But here is a snippet of how the block will be created in code. So we have our index.javascript. JavaScript is going to be the driver of our block. We're going to register our block from block.json. Our block.json is really the big driver of the block definition. It defines the name of my chart, or the name of my block, which I'm calling chart creatively, the title, and then those 4 attributes that I called out earlier. So the data, which is going to be our sheet URL, the column that we're going to create the chart out of, our chart title, and our chart caption, and all of these are going to be strings. Our edit interface is going to use primarily the text control, because we're dealing with text, we're dealing with strings. So I'm just going to have text controls, which is the Gutenberg fancy way of saying I want an input field. So we're going to have a separate text control for our Google Sheets URL, our column, and then also, I didn't have room to fit this on the slide, but also the title and the caption. And our edit UI is going to look something like this. So what I chose to do is have all of these text controls in the inspector panel, kind of off to the side, leaving the editor UI kind of as a home for a placeholder for where the chart will go. You can type in the caption over here at the bottom below the block. And a content editor can just add this block into their WordPress site and go. It was a super quick overview of dynamic blocks, and I apologize because I really want to get into step 2, which is processing all of the data from our Google Sheets. So the strategy that we're going to use, because this is, we just created a dynamic block, and we are going to be rendering the dynamic block on the front end using the server side. We want to do all of our data processing on the server side as well. So we're going to process all of this in PHP, because that is the backend language that WordPress runs on. And we're going to use a really neat class in WordPress called WP_HTTP. And we're going to use that class to read the data directly from Google Sheets. So in the PHP, we're going to get some data from the block attributes. The first piece of data that we're going to need is that API key. So you can go into Google, you can go into your Google account, and your Google account will let you get into kind of like a developer mode, and it will let you create an API key. You will need to store that API key somewhere. You have a few options to do that. I personally like having a custom setting that I also define in WordPress, where a content editor, for example, can go and store that API key, and then it's just saved to your site. You could also add it to your code directly. That's not exactly super secure. You could also add that as a GitHub secret, which is a little bit more secure. That option is up to you, but in order to use that that WP HTTP class to read information from Google, you will need that API key. And then the other data I'm going to need to be able to read this Google Sheet is first the URL of the Google Sheet, and then also that column that we want to create the chart out of. So what I'm going to do is extract the sheet ID from the Google Sheets URL. And all of these sheet URLs, if you kind of take a look at the URL when you're in Google Sheets, they all have sort of the same format. So it's always docs.google.com/spreadsheets/ and then a bunch of characters. Those bunch of characters are the sheet ID. So we want to extract that so that we can get that information via the API. The next piece of information that we're going to need is the range of data from the spreadsheet that we want to create the chart out of. And this is where column comes in. I make an assumption that these sheets, the first row of the sheet is basically like a title header row where from the Google Sheet that I put on the screen before, that title row had name, states, major, forget what other columns there are, but that first row isn't really part of our data. That's more defining the columns. So what I want to do is set my range from the second row to something that is large enough to capture all the data in the sheet. In this example, I chose 1,000. You might want to take a look at your sheet to see what number might be best for you, but you want to make that last number really, really large. And then this all sets us up to make that call to Google to get our data. The snippet of code that I have on the screen, it first creates a new instance of that WP HTTP class. It sets up the URL that we're going to use to call the Google API. So that Google API always starts with sheets.googleapis.com. And then we're going to add our sheet ID that we extracted before, and then the range of data from the column that we're reading, and then finally our API key. And that API key is like the lock that sort of unlocks all the data from Google. So we're gonna get our raw data by calling the get class in the WP HTTP, the get function from the WP HTTP class. And then we're going to decode all of this raw data. So it comes in as a JSON string. We're going to decode all of this data and we'll get an array that looks something like this. So the array, it's an associative array. So the array is going to first tell us our range, which is where in the sheet that we extracted all of this data. So I extracted data from a sheet called class data from column C, row 2 through 101. And then following that, it's showing me all of my values. So all of my values are the different states where these students are coming from. So my first student's coming from California. The second one is coming from South Dakota. The next one is North Carolina, and so on and so on. So we have our data from our Google Sheets, but we're not done yet. What we really need to create our visualization is to count the number of students from, I have a typo here, from each state. I do not mean each major, I really do mean each state. So we're going to need another PHP function to count all of the unique values in that data that we just extracted from Google. So we're going to we're going to have a for loop, and we're going to create a for loop that will loop through all of the values in our raw data. And we're going to say, okay, well, if we come across a state that we've already come across, then we're just going to create a counter for that state, and we're just going to keep adding one, adding one, adding one. So if we go through this loop and we say, okay, my first student is from California, I already have somebody from California, so I'll add one to that bucket. If I don't have somebody from California yet, if I haven't come across somebody from California, I'm going to create a new California bucket and say, okay, well, I have one person from California, and then I have one person from North Carolina, and then, oh, look, I have another person from California, so now I'm up to 2. So eventually, this for loop will count all of the students from all of these states, and I will end up with a much nicer looking array that, again, is an associative array, but now it's saying, okay, I have 6 students from California and 6 from North Carolina and 2 from Maryland, and so on and so on and so on. So this is something we can work with to create a chart. That was a whole lot of work, but now we can actually create our chart because now we have data that we can work with. So circling back to our charting requirements, we want to make this chart accessible so that the largest number of people can access this data and understand this data. We want to make it responsive so that people can look at this data and find this data on whatever device they are on. If somebody is on a laptop, a tablet, a phone. And this particular example is a fairly simple example, so we want to keep our visualization fairly simple. So today we're going to create a horizontal bar chart. So something that looks like what I have on the screen. So on the left-hand side, I have the list of all of the states, and going from left to right, I have bars that will visually show how many students are from each state. So how many students are from California? There's quite a few from California and North Carolina, maybe not so many from Wisconsin. At the bottom of this chart, I have my x-axis showing a sense of scale, so 0 to 6, because the most I have from any given state is 6. This is obviously a very small university here. And then finally at the bottom, we have a caption saying all of our students come from all over the United States. And this fall, most of our students are coming from one of 4 different states. So let's figure out how to make this. So there are a few options. There are a lot of libraries that somebody can use to create SVGs. D3 is one of them. It's a really great one. But in this talk, I really want to talk about how to create a chart from scratch using SVG. So the first question is, what on earth is SVG? So SVG stands for Scalable Vector Graphic. And it is based in XML, which is a markup language fairly similar in structure to HTML for folks who are familiar with that. And it is specifically a standard that helps you create images for anything that is 2-dimensional. So SVG, unlike other image formats, it is all code. If you open up an SVG file in a text editor, you will see code that you can read. In contrast, if you open up a JPEG in a text editor, you are going to see a lot of characters that might not even be recognizable, and it's going to be a giant looking mess. And so SVG is all code that a human can read if you know the language, and we're going to go into that language a little bit here. There is no image loss because code scales. Code scales very nicely. In an SVG, you can say, I want to create a rectangle, and these are the general proportions of my rectangle. I want it to be twice as wide as it is high. And you can scale that very easily on a small screen or a large screen. So you don't get any image loss that you would if you tried to like zoom in on a JPEG, for example. Also, because an SVG is all code, it tends to have a smaller file size than something like a JPEG or a PNG or a GIF. And that code is semantic. You can make a semantic SVG by using the correct tags, just like you would in HTML. And you can also add ARIA attributes and roles to these tags to make your code readable to the widest possible audience. So let's dive further in and write some of this SVG code. So as a general overview, SVG, you start with the SVG tag, and you start out with this XML and S kind of standard URL. But the points that I want to point out in this SVG tag are the ARIA labeled by and the width and the height. So the width and the height are really important for browser rendering. So it tells the browser exactly how big, how much space does this SVG need to take up. And this is very similar to, if you're familiar with the image tag in HTML, this is very similar to setting a width and height there, because it's a much nicer experience if the browser already knows how big this particular image is going to be. Now the ARIA labeled by attribute here is a pointer to what I have in this particular example, to my title. So I'm in my SVG tag, I'm saying this SVG is labeled by the element inside my SVG that has the ID of my dash chart, which just happens to be my title tag. So this SVG, when it's read by a screen reader agent, it's going to say, okay, the label for this SVG is the title. So I am going to read out whatever is inside my title tag as the label, as the descriptor for this particular SVG image. So that is really the first step in making sure that a screen reader user will be able to understand the context of what is in this chart. So one of the keys of this title is that you really want to set up that context for what kind of visualization you have. So in this case, I'm saying I have a horizontal bar chart. So I'm describing what's going to be on the screen. And this is depicting the number of users that are attending our university from each US state. So it's also setting up the expectation of what is going to go into this chart. After that title, you can put all of the shapes that are going to go into creating this chart. So before we get into shapes, we do need to set that SVG height. So on my previous screen, you kind of saw like I had height, but I didn't really specify a number because I need to calculate how tall this chart is going to be. So the fun thing about charts, especially when you're creating a chart from some dynamic data, is that you don't really know how many bars are going to be in that chart until you really take a look at the data and see how many unique values you have. So we need to do that calculation. So now that we know that we have 10 or 12 different states that we need to chart out, we need to do that calculation. So we need to say that our chart height has to be the number of unique values in our chart. And we're going to multiply that by how tall, like how physically tall we want each horizontal bar to be, plus how much space do we want in between each bar in our chart. And if we do that multiplication and we give just a little bit more room, so my second line of code here, my first line of code is doing that multiplication. The second line of code is saying, I want to take that chart height. So the sum of all of the heights of the bars plus all of the gaps in between. And I'm going to add another 40 pixels to that to give myself a little bit more space for something like the x-axis and the caption. That chart height plus my little bit of extra is going to be the height of my SVG. So my SVG declaration with my height is going to look like this. I'll have my SVG tag, my ARIA labeled attribute going to my chart, my width. I want this chart to take up 100% of its container. And then the height is going to equal that SVG height that I just calculated. So next up, we want to create those X and Y axes to give our chart a little bit of shape. So I guess geometry reminder, the X-axis goes across from left to right, the Y-axis goes up and down, and the X-axis in particular on this particular chart is going to be aligned with the bottom of our chart. And I did Google this. Axes, spelled kind of looks like axes, is the plural of axis, singular. So I just found that a very, very fun bit of English grammar. So anyway, SVGs. The way that an SVG defines the coordinates of the elements inside of it is that the top left of our SVG image is the 0th pixel on your x-axis and your 0th pixel on your y-axis. So you start in the top left at 0, 0, and all the way across to your right is your what I'm calling max X here, but that's really the width of max X is the width of our SVG. Max Y is the height of our SVG. So this is going to be relevant when we start drawing these SVG shapes. So in order to create the x-axis and the y-axis in a chart, they're basically just lines. And the SVG markup has a line element. So it just says, I want to create a line and I want to start this line at this XY coordinate. And I want to end this line at this other XY coordinate. And all you have to do to create a line, going again, channeling geometry class, is to set our 2 points, and this line element will just draw a line in between the 2 points that we define. So the first point is defined with the attributes x1 and y1. So that is our first point. So we want to say, all right, I want the y-axis to start kind of 20% of the way in. And I want my y-axis to start at the top and go all the way to the bottom. So my first point is going to be 20% of the way in, and 0 for my y value. So it's going to start all the way at the top. And then my second point is going to be, again, 20% of the way in from the left-hand side of the SVG, and it's going to go all the way to the bottom of our chart. So I have that as kind of a variable of chart height here. So chart height is really going to be that multiplication that we did in that earlier slide. So chart height is the number of bars times the bar width plus bar gap. Stroke just tells me what color I want this axis to be. So I am choosing black, which is defined in hex as 0, 0, 0. And I want this to have my axis to have a width of 2 pixels. So that's my stroke width. I'm giving this line a role of presentation because I don't really want the screen reader to call out every single like both of my axes. I don't necessarily want the screen reader to say, there is a line here that is my y-axis, there is a line here that is my x-axis, because that's too much information for somebody. That's just a lot of information. It's a lot of unnecessary information, and it's not exactly germane to the data in our chart. So a role of presentation will allow the screen reader to just say, okay, this is presentation. This isn't actual data. I don't have to read this out. My x-axis is drawn in a very similar way. It also has that role of presentation, and it's going to go straight across the bottom. So my first point is going to be, again, 20% of the way in, and it's going to go all the way to the bottom. So both y values are going to be the chart heights. Make sure it stays on the bottom. So this line is going to go 20% of the way to 100% of the way down or across my SVG chart. And again, I want this to be a 2 pixel wide black line because it's my axis line. I want it to be fairly neutral. And then I also want to have my scale along the x-axis. So my scale is going to be from 0 to the maximum number of people who are from a particular state. In this example, it's 6. So I want to depict this in my SVG, and I'm going to use this with another element called text. So the cool thing about SVGs is you can put text in it, and it's so great. I'm also giving this text element a role of presentation because I don't necessarily want a screen reader agent to read this particular piece of text out, because all of a sudden somebody's going to come across this and the screen reader is going to say 0 or it's going to say 6, and there's not a whole lot of context, and it's also not the point of the chart. The chart has other information in the bars that we're going to get to in a little bit. So I'm going to have my text kind of at this role of presentation, just so the screen reader can present it to somebody who's visual, but they're going to get that information through the bars that we'll see in just a second. So I'm going to set my scale from 0 to my max value. In this case, it's 6. And this is kind of what everything looks like together. So what I want to do is group all of these with the SVG G element. So G for group is just a little abbreviation for that. And I'm going to put all of these lines and my scale, my text scale, into this particular group. Now we're at the fun part. Now this is the part where we create the actual bars that has the actual data that everybody cares about. So the first thing that we want to do is use this G element to create a second group that's going to house all of these bars. And this group is the important group. This has all of our data. So this one is going to get an ARIA label. For brevity, I just put an ARIA label here of chart data. I highly recommend being as detailed as possible with your ARIA labels, especially if you have a lot of information, if there's a lot going on in your particular visualization. There are a lot of people who will argue that short ARIA labels are really good. I would almost argue that if you have something to say, and if there is very particular information or very important information that you want to convey, make that ARIA label as long as you need to. You don't need to go overboard. More isn't necessarily better, but if you have a lot of information, more might be sometimes better. So to create the actual bars, we're going to loop through that array of data that we processed earlier, and we're actually going to create a subgroup for each bar that's going to contain the bar itself, a text label, and an ARIA description that will describe exactly what is going on with these bars and what each bar in this graph means. So the subgroup for each bar element is going to have a role of list item, because this is basically a list of information. We're going to have an ARIA label that's going to be automatically generated. That's, in my case, it says there are number of items, entries under label. So what this is really going to sound like in real life for this chart is there are 6 entries under California. There are 4 entries under Maryland. This ARIA label is very generic. If you're in a position where you know that you can be more specific with this ARIA label, I highly encourage you to do that and say there are 6 students from California. There are 4 students from Maryland. And the last attribute I have in this group is a tab index of 0. This tab index is very important because it allows a keyboard user to be able to tab into the SVG and focus on each of these bar elements within the SVG. So because an SVG is code, just like with your HTML code, you can tab to a link. You can navigate with a excuse me, you can navigate with a keyboard to any sort of focusable item. And this tab index of 0 will allow this group to become a focusable item. So inside this group, we're going to have our bar elements and our label elements. So the bar is going to be a rectangle, which conveniently SVG has a tag for rectangles. It's abbreviated to rect, R-E-C-T. We're going to give that rectangle a role of presentation because the group that the rectangle is in is what contains all of that information for this particular bar. So because we're grouping the summary of what this bar represents in our group, we can let the rectangle take that more of a presentational role. We're going to set there are 4 attributes that you need to create a rectangle. So the first attribute is your X value, where your rectangle is going to start. So that's going to be the top left corner of your rectangle. So the X and Y coordinates of that top left points. The X is just going to be the offset, like how far into the SVG as a whole I want this rectangle to start. So if you remember from my axis, I have my axis 20% of the way in from the edge of my SVG. So maybe this rectangle could start at like 22% to give a little bit of space between the rectangle and the bar. It depends on your aesthetic. My Y value is going to depend because it's going to depend on where this bar lives in the SVG. So the Y value is going to be another calculation of the number of bars I've rendered so far times the height of each bar plus the gap between each bars. And then the last 2 attributes to create a rectangle in SVG are the width and the height values. So we want to know how wide this rectangle is going to be and how high this rectangle is going to be. And the SVG is going to start drawing this rectangle starting from that top left point. It's going to draw it out by its width and down by its height. So the width is going to be the width of this particular bar, and that is calculated based on the data. So the largest number, the pieces of data that have the greatest value, that data is going to take up 100% of the width of my SVG. Maybe a state, so California had the most, so that had 6 people, so that is going to take up the entire width of my SVG. Maybe another state that had only 3 people will take up 50%. So that is going to be automatically calculated by based on the data. And the height is a fixed height because we want each bar, it's a horizontal bar chart, so the width varies, but we want the height of each bar to stay the same. So the bar height is whatever we want to set. And then finally, I have my fill. The fill is the attribute for what color I want my rectangle to be. And in this case, I chose purple. So that is a hex value of 00F. So to, again, circle back about that bar width, the width of each bar is going to be a percentage. It's going to be how many students are coming from the state, and it's going to be calculated as a percentage of value divided by max value times 100 to make that a percentage. And then my bar label. In the example SVG that I showed, the bar label was all the way on the left-hand side of the SVG. So again, I'm going to use that text element. I'm going to give it a role of presentation because the group that this text element lives in has the ARIA label that describes what is going on with both the bar and this particular label. My X and Y coordinates set where this label lives. So just like the bar had a Y value of the number of bars so far times the bar height plus gap, this text label has that same Y value. I want it to be black text, so that's my fill. I can also set a font size for text elements. So I'm going to set a font size of 16 pixels. The font size in SVG is always set by pixels. And then inside this text element, I'm just going to put in my label, again, calculated from or grabbed from the array that I processed earlier. So all together, I have my container group that is going to have that role of a role of list, because we have a list of items that we're going to be going through. So that will semantically say, okay, I have a list of states that is showing me where all of my students are from. And then each individual bar is going to be its own subgroup inside of this container list group. And each of these subgroups has a role of list item. Each of these subgroups also have an ARIA label that describes everything. And these groups will contain both the rectangle element that will draw my bar and my text element that will provide my bar a visual label. And then finally, the last part of this SVG that will kind of tie everything together is that caption element that we're going to put all the way at the bottom of the SVG. So it's actually what I chose to do. You can, you have a couple of choices when it comes to the caption. You can use that text element that comes with SVG to put the caption as an element at the bottom and kind of draw it in at the bottom of your SVG. What I figured is more semantic is to wrap the entire chart in an HTML figure tag. So the figure will say, okay, I have this image element that is my SVG. It's the SVG that I just drew. And then my fig caption, I can use my fig caption HTML elements to write out this caption. And that will also semantically tie my SVG to this particular caption. And that caption can give my SVG even more context than it had. So we have the title giving it context. We have this fig caption giving it context. And then we have all of the information inside of the SVG code giving each individual piece of data context. And then on the front end, we have this bar chart that has all of our bars, it has all of our labels, it has our caption at the bottom. And I don't really have time to give an interactive demo, but a keyboard user, a screen reader agent can go and navigate through each element of this bar chart to get the information from each individual bar, each individual state in this case. Just a few more quick accessibility tips. As with everything else on a website, please pay attention to color contrast. Color contrast is super important, especially if you have a bar chart that has, if you have a more complex bar chart that has two bars next to each other, you want to make sure that those two bars also contrast with each other so somebody can tell the difference between like a green bar and a red bar versus a green bar and a yellow bar, or a green bar and a blue bar. Like there are definitely colors that sort of blend in with each other more than others. I highly recommend limiting animations because it can be very distracting for a lot of people. Myself included, I find animations incredibly distracting. You can add the bar values within the SVG as text to each bar. That was a little bit much for this particular presentation. Another nice trick that I have seen is including a HTML table alternative to the bar chart, and that just to give another presentation of this data as an actual data table. Like I said before, writing meaningful labels, writing detailed labels, as much information and context as you have, I find very valuable because a picture has a lot of inferences in it. A chart has a lot of inferences in it that if you can't physically see the charts, it is helpful to write out those inferences as a label. So I find writing ARIA labels more of an art. So I think that that's just, it's something that I enjoy doing. And also test. Find as many devices as you can, find as many agents, like user agents as you can, find as many screen readers as you can, and find as many people as you can. The more people, the more perspectives that you have looking at your charts, looking at your visualizations. You get a lot of different perspectives from people and you learn about different use cases that way. So don't shortchange your testing. And that is it. We made it. This again is my 5-year-old when she was 4. But thank you, everybody. This was quite a lot. You can see this in action. I wrote a plugin called Basin Block. All of these links will be available in my slides. My slides are publicly available. I have a bunch of reference material. And finally, I know I'm running really short on time, but please stay in touch. These slides are available at talks.jhalabi.com/svg-in-WordPress. And again, you can find me on most socials at Joni Halabi. Thank you so much, everybody.
All right. Hold on. We have something in the chat. Just making sure. Oh, thank you. And then we had a couple of questions. Do we have time for questions, just out of curiosity? I don't know. Okay. Let's do one question.
Sorry, I ran over. I know.
Oh, no, it's okay. I just want to make sure one of these gets answered. 3 minutes. Okay, we have 3 minutes. Okay. If I want to make the bars grow in vertical direction, I only need to invert in the width and height, or are there more steps?
That's most of it, actually. I did write an inversion to do a vertical chart, and basically, so for the bars themselves, yes, you basically just invert your X and your Y values, and you're most of the way there. More of the work kind of comes with drawing the axes. So you do have to pay attention and kind of move the scale. So on the horizontal bar chart, I have the scale obviously on the x-axis. When you kind of flip everything over, you want that scale on the y-axis. So you do have to do a bit of flipping and a bit of math, but it is relatively simple to switch between the two.
Will it be an issue if font size only set in pixel and SVG rather than using EM?
Probably. Not gonna lie, I definitely prefer EM or REMS to pixels. Sometimes it depends on the browser. Sometimes the font size does get a little bit weird, especially if you're zooming in, like if you're using the browser zoom. You could probably, like, you could probably do something in JavaScript. I haven't really played around with that. That's a really interesting question. But you could probably do something in JavaScript to change the font sizes if you can read the zoom level too, because just like an HTML element, you can use JavaScript to target an element inside the SVG, because it's really, you're basically just targeting selectors.
Okay, sounds good. All right, one more quick one. I must have missed it. Where's the graph accessing the data? State, number of students.
So that particular spreadsheet was just a random spreadsheet in Google Sheets. This example was from Google Sheets. So as long as you have it has to be a publicly accessible Google Sheets. But as long as you have a publicly accessible Google Sheet, you can do something like this. You could probably also work with WordPress and open up the media library to import CSV, and you'd have to adjust the algorithm to read from the CSV in WordPress if you want to kind of go that way. But yeah, I was using Google Sheets for this particular example.
All right. Well, thank you for attending this session with Joni. You can continue the conversation in the chat on social media with hashtag AWPA11day and WPAD2023. We also appreciate it if you go to 2023 waccessibility.feedback to provide any anonymous feedback to our speakers that can enter to win a t-shirt while you're there. The other thing you want to know is when you close this session, the WordPress Accessibility Day admin want to share that due to technical difficulties, this Zoom webinar, they did send out a new webinar link in your email. It'll be from Zoom. So it's not from WordPress, it's from Zoom with a new URL. So you're going to want to join that one for the next session, okay, which is on animation and something with WordPress animation. I know that. And then so please leave this webinar and join the new one, okay, for the next webinar. So thank you all so much, and please leave some anonymous feedback on at that at 2023 WebEx or WPAC accessibility /feedback, and then stay tuned for the next session at that starts in 10 minutes. And don't forget to visit our sponsors pages. Thank you, everyone.
Thank you to WordPress Accessibility Day 2023 sponsors. Platinum sponsor, Equalize Digital. Equalize Digital's Accessibility Checker plugin is an automated accessibility scanning tool that helps WordPress websites become and stay accessible. Platinum sponsor, Gravity Forms. Gravity Forms is the professional form builder that you need to create beautiful, powerful, and accessible forms. Gold sponsors, 20i, DQ, Empire Caption Solutions, Pressable, and WP Engine. Silver sponsors, CodeGeek, Drake Cooper, GoDaddy, Lone Rock Point, NerdPress, Overnight Website by Kinetic Iris, Riola Networks, A11Y Collective, and The Blogsmith. Bronze sponsors, Accessicart, Green Geeks Web Hosting, Hall Analysis SEO Consulting, HDC, ITX, IvyCat, MetaBox, Pixel Chefs, Simply Schedule Appointments, SiteGround, Termageddon, Underrepresented in Tech, Weglot, and Yoast.